Services in Android are a top level component that allow us to execute long running operations that don't require direct user interaction. And as such, they do not provide a user interface. Services are useful whenever we're performing some operation that will likely or can extend past the lifetime of the component that triggered it, or that should continue to operate even if the user is not actively interacting directly or indirectly with that operation. So, examples of this would be things like playing music or performing large upload or downloads of files, or pretty much any operation that may extend past the time the user might be interacting with a component. If they're likely to put that activity in the background, for example, but the job still needs to be completed, then the recommended approach is to offload that operation to a service. Services can be unbound or bound. When a service is unbound, we say that it is started. The difference between the two, a started service is executed with a call to start service, and once started, will continue executing until it is explicitly stopped with a call to stop service from an external component, or stop self from within the service itself, or some variation of stop self, such as stop self result or something. The idea behind a started service is that once it's essentially started, you the component that starts it does not have a direct way to communicate with it. Rather, the idea is that the service is just allowed to execute to completion, at which point it will sort of handle it handles its own life cycle and will clear itself from memory. A bound service, on the other hand, you connect to a bind service from a client from some external component with a call to bind service. And once bound, you maintain a connection through an iBinder object that allows you to maintain communication with the service. So you can send updated information or new commands to the service to have it change its behavior in a way that you could not if the service was started. You can have multiple components connected and sending messages, and once the last component disconnects, the service will again stop itself. Depending on if you start or bind to a service, the life cycle will vary. First, regardless of which method you use to run the service, the onCreate function will be the first to execute. Now, it should be noted that a service can have start service called on it multiple times while it's still running. Similarly, bind service can be called multiple times while it is still running. But onCreate will only be fired the very first time the service is loaded and its lifecycle started. So that will only trigger once. Subsequently, every call to start service will trigger its unstart command. At this point, the service is running and is performing whatever task is required, and it will remain in a running state until it is explicitly told to stop, as mentioned before, with a call to stop service or stop self. At that point, its onDestroy is triggered and the service is shut down. If a service is being bound to, then the onBind is called, will be invoked for every client that binds to the service. When all clients unbind, then unbind will be called, followed by onDestroy, and then the service is shut down. So let's look at an example of using a service. And what we are going to do here is we're going to create a small timer application where we're going to offload a timer to a service so that in theory the timer could continue to run. If we were to say kill our activity, we could have a countdown timer running via a service. So I have here a start button that I will use to trigger the service. And I'll start by simply creating a new service. I'll call this my timer service. It'll be set to exported, which means that external components could in theory start it. I don't need to do that. And it's going to be enabled, which allows it to run in the first place. So I do want it enabled. So I'll hit finish. And two things we're going to have. We're going to have our timer service class created, which is a subclass of service. And inside of our manifest, we'll have an entry for timer service because it is a top level component, just like an activity. So it gets an entry inside of our application manifest. And my goal then, I'm going to override onStart command. And my goal is going to I'm going to return the superclass's implementation of onStart command. However, prior to doing that, I am going to have a function run timer. And the goal of run timer will be to I'll create a thread, which I will need to, because a service executes in your application's main thread along with all other components, unless it's been offloaded or it's being executed in a separate process, which you can specify in the manifest. But if this is a normal, a basic local service, then it's running in your application's process and it's running on your application's main thread. So if you intend to use any sort of blocking operation, then you need to use some sort of concurrency scheme, whether threads or coroutines. I don't have the coroutines library added here, so I'll just use threads. Plus, it will give me an opportunity to discuss a few considerations. So my timer, let's do 100 down to 0. And then I will sleep 1000 milliseconds would be 1 second. Let's do 100 milliseconds so we can get a much faster countdown. 1/10 of the time. So I guess I could have just done a 10-second countdown timer. And so this is my run timer function, and I will call run timer from onStart command, since this is what gets invoked. And then all I need to do to have this service execute is call startService with a reference to timer service. So I will call startService from my button and now we'll see what we get. So at this point, I will click start. And once I click start, you will see on the emulator's log that we're getting a countdown. But for simplicity, let's actually embed the emulator into the IDE so we can see both of these things happening at the same time. And now we can see that hitting start runs my timer from 100 down to 0. And that's going to happen even if I say start a timer and then exit the activity. my timer still executes because the timer is executing in a service. Now, what's interesting to note here is that even at this point where my service has, the timer has run to completion, and arguably my service has performed its task, at this point my service is actually still in memory. Nothing has actually unloaded it, because whenever a service is started, it must be explicitly stopped. And we can demonstrate this by simply overriding on destroy, and we can verify that this log message will never be printed. So running my service again. In fact, for future reference, I'll just set this to 50 so we can get an even faster countdown. Executing start, I'll see that when I get to 0, I get nothing. There is no log message telling me that the service has stopped. So, of course, in order to achieve that, I need to make sure that I call stop self, in theory, stop self, without an ID. This is the same as a call to stop service from an external component. So this will stop the service immediately. And that may be what we want in a simple scenario like this. So I'll call start, and here we see that once we get to the end, the service is stopped. Now, the dangerous part about calling stop self without the ID argument or a call to stop service externally is that you may actually stop the service prematurely. You may stop it before it's ready. For instance, a service runs as a singleton and can actually have multiple calls made to it while it's in memory, and it will process all of those calls. By default, a service that has startService called in multiple times will execute both requests concurrently. So for example, and you'll have to kind of pay close attention here, or maybe I need to just speed up my, or add more time rather to my timer so it's more visible. I'll do two 20-second timers. And what you're going to notice here is that once I start one timer, and we'll get down to, let's say, 12 seconds, I will hit start again. And you'll see that we have an interleaving of my countdown timers. But the problem is, once I get to the end of the first timer, well, this is one of the other problems I wanted to mention. Once I get to the end of the first timer, the service actually has stop self invoked. Now, the reason you still saw my second countdown timer running is because I'm using threads, and my threads right now are not aware of the life cycle. It's almost a quasi memory leak. Well, it's a memory leak. So the thread doesn't end just because the service has ended. The thread keeps going. If I was using coroutines, we would have seen a more direct ending of the operation. And I could, in fact, write my threads in such a way that they'd be aware. Well, I could write my thread logic and perhaps set a flag in my onDestroy so the thread can be aware that the service is shutting down and that it should exit. So I could do all of that, but I left this here so we could actually see that that's what a thread does. Invariably, it can cause memory leaks if not used properly. But we can see that my onDestroy was invoked even though my second timer was still executing. So this is sort of where stop self that takes the argument comes in, because every time onStart command is invoked, start ID is going to be given an ever incrementing value. And whenever you call stop self with an ID matching one of the start IDs, every call to stop self that has a start ID that is lower than the most recent will be ignored, preventing the service from shutting down. Again, presume for a second I'm not using threads that ignore the shutdown. So the proper way to actually write this would be to leverage start ID and pass that start ID to stop self. Now it should be noted that it's not going to be as simple as declaring a variable setting it, initializing it, or updating it here. And then passing it to my service, or to my thread rather. So it's not this simple, because in this scenario, I'm only operating on a single instance of start ID, which doesn't change anything for my application's logic. Essentially, every time I do a new run of start ID, or rather start the service, the start ID is updated, which means that whoever calls stop self first, whichever thread calls stop self first, will still use the latest start ID, because every time I call on start command, start ID is updated. So the first thread to end is going to call stop self with the latest start ID. So my logic needs to be a little more involved. And depending on your goal, depending on your use case, you can do this a lot of different ways. Perhaps one of the easiest ways, if I had a scenario like this, where I had timers that I wanted to run concurrently, but I only wanted the most recent timer to shut the service down, so all timers run to the end, then perhaps the easiest way would be to just create my own threading class. That extends thread. And I would have this timer thread accept an argument I need to remember to use private more often. So I could have it accept a local version of its own ID. And then I'd grab this logic and I'd place this inside the run function. And, oh, why did I put state ID? That should be start ID. And stop self cannot, oh, I can make this an inner class. So now we can access functions and the properties of the outer class. So this is my timer thread, just looking at it quickly. Okay, I think this is right. And then whenever we call run timer, well, what we'll do is we don't need to store this value. We will simply call run timer with the start ID. So we'll pass the start ID that we received as an argument in onStart command to run timer. And then run timer will create a timer thread with start ID, and then we'll start it. And in this scenario, again, ignoring the fact that my threads would keep the service alive through just a terribly coded memory leak, we can now see that if I run once, twice, even 3 times, so we see interleaving timers, because it's all running concurrently, we'd have to recode this to have it execute sequentially. But notice at the end, we don't see stopped. The most recent start ID is not being used when the original or the first call to stop self is invoked. The most recent ID is only used when the last call to stop self is invoked. So the service shuts itself down when it's finished running all the timers. So a proper implementation of a service that uses stop self would look something like this. Now, this is not a panacea. This is not necessarily a solution for every situation. For example, let us say we had a service like this, but the timers were different. That is, some were longer, some were shorter. Well, we could potentially have a problem with this logic as written if we had let's say we had a 10-minute timer as the first timer and a 1-minute timer as the second timer. Well, in that scenario, the 1-minute timer would clearly be invoked or have its stop self invoked before the 10-minute timer. And in that situation, we would have a problem where the 1-minute timer having executed with the most recent start ID would then kill the service even though the 10-minute timer was still executing. So we may have to come up with more involved logic to facilitate the service doing a proper shutdown only when all tasks are completed. But regardless of what your use case is, you'll essentially need to come up with a mechanism to do that. But as we can see, the service class itself is extremely useful because I am able to keep an operation running even if the activity that's running that operation is no longer in memory. Again, because this is a thread, even if I put this in an activity, it would still work. But this is essentially the basics of using start command, or rather calling startService on a service, and that invokes onStart command. Next, we're going to look at how we use a service that we can bind to have communication going both ways.